In this tutorial, we're going to examine a contingency table to see if the variables in the contingency table are independent of each other. Now, I've created this contingency table from the original Stats 101 dataset using the pivot table tool in Excel. If you're not sure how to do this, please take a look at the tutorial called Creating Pivot Tables. Now, pivot tables are sometimes a little fussy to work with, and when you try moving them around, they do some wonky things. So what I like to do is to make a copy of the pivot table. Click in cell E7 in this particular case, and select the whole pivot table here, just like that. Then we can go to the Home tab, copy, and then let's just move down a few rows here, and we're going to select Paste Values. Now, what we've done here is we've made a copy of the pivot table, but we've removed all of its functionality. So all we're left with here is a bunch of text and numbers. I'm just going to put a box around those cells there, and that it has nothing to do with the functionality of the thing, but it just allows us to focus in a little easier on the numbers there. The last thing I'm going to do before moving on to looking at the observed frequencies, the expected frequencies, pardon me, is to just label this thing observed or actual values or frequencies. That is, these are the values that we actually observed from Stats 101. That is, that there's 13 blue-eyed females and 12 blue-eyed males and so on. Now let's drop down a few rows, and we're going to create another table of expected values. The expected values are the ones that we expect to see if these two variables, gender and eye color, are independent of each other. How do we do that? Well, we're going to build a formula here, and the first one is going to look at this cell here, that's blue-eyed females, and I'm going to put the cell right in here and build a formula that will give me the expected frequency if these two variables, gender and eye color, are independent. Let's do that. Press equals. Now let's select the column total, which is in cell B15, and I'm going to press the F4 key a couple of times to fix row 15. Why row 15? Well, that's where we find the column totals, and we always want to be going back and grabbing the column totals from row 15. Times, and now let's click on the row total, which is found in column E. And again, column E, because that's where we find the row totals, and we always want to be going back to that particular column there. So press F4 to fix the E part of the formula. Finally, we divide through by the grand total, which in this case is the 100 in cell E15, and press F4 to fix that. So we've got dollar signs around both the E and the 15. Okay, that gives us a number 15, and that 15 says that if gender and eye color are independent of each other, we would expect to see 15 blue-eyed females. Let's copy that particular formula across. Now it's all going to turn yellow, but that doesn't matter. And down a couple of rows here. And that gives us a table of expected frequencies here. Here, I'm just going to put a little box around, and you can see here that the row totals and the column totals are the same, but the numbers within the cells here, these 6 in the box, are the expected values if these two variables are independent. Now, if this were your first stats course, Business 306 or Business Admin 111, we would just look at those numbers there and ask, well, are they significantly different from each other? For instance, is this 15 here significantly different from the 13? We expect to see 15 blue-eyed females, and we actually observe 13 blue-eyed females. Is that significantly higher? Well, in 306 or 111, it's really a judgment call. But in 307, I'm going to take you just a step further and show you how to calculate a p-value for a chi-square test. Let's drop down a few cells. And I'm going to go up to the formula ribbon and select More Functions, Statistical, and chi-test. Now that brings up a dialog box here. The first argument that it's asking for is the actual range. These are the observed frequencies, these 6 values up here in the observed table. The expected range are these new ones that we've created, these 6 values down here in the expected table. Press OK, and the number that we get is a p-value, in this case 46%. Now that p-value can be compared to an alpha value. Let's say we had an alpha value of 5%. If the p-value is less than the alpha value, then we would reject the null hypothesis that the two variables, in this case gender and eye color, are independent of each other. In our particular case, the p-value is much higher than the alpha value, and so we cannot reject the null hypothesis, and therefore conclude that the two variables, gender and eye color, are independent of each other. This concludes the tutorial.